Okay, here we go. So section 1.1 is going to be a review of functions, kind of just a little bit of everything about functions from pre-calc. So just remember that a function is basically something that takes an input value. We usually call that x. You plug it into some sort of operation called a rule. Usually we name it f or g or h. And then what comes out of it is called f of x, which we refer to as the output. Okay, so that's the middle school definition of a function. The calculus definition of a function is listed on here. A rule that assigns to every element x in a set A. So we would be calling this set A, all the x's. Exactly one element comes out called f of x, as in a set B. Okay, so set A is basically your x's, which we call the domain, and set B is going to be your y values, which we call the range. Okay, the y values of a certain point in calculus is usually referred to as an f of x value. So you're used to seeing points called x's and y's. We're going to graduate to the next level where we now call them x and f of x. Okay, so it's going to take a little while to get used to that change. So I have a graph here, and I'm just going to pick an ordered pair, maybe this one right here. And I'm going to say, what's that ordered pair? That one looks like 2, 4. That's 2, 4, okay? Normally we would say something like x is 2 and y is 4. The advanced way of describing that point would be to say that when x is 2, f of 2 is 4, meaning the y value at 2 is equal to 4. Let's look at something else. So domain and range. We did last year pretty extensively, so we're coming back to that for a moment. Remember, domain is how wide a graph is. So this would be like your domain, how wide this graph is. And range is how tall a graph is. A function, I should say. Okay, let's practice those two things. So for the first one, we've got what is f of 1 and f of 5. Remember, this is like saying, what is the y value when x is 1? So when x is 1, the y value looks like 3 to me. And then f of 5 is asking for the y value when x is 5. 2, 3, 4, 5. Looks like, I don't know, what do we want to call that? Negative 2/3 maybe? Negative 3/4, something along that line. Domain and range. So we're going to say for domain, we want to look at how wide the graph is. And it looks like this graph goes from 0 on the x-axis up to 7. So we're going to write it as 0 to 7 with both values included, because to my eye it looks like it does touch both of those x values. And then your range will be how tall the graph is. So like lowest point to highest point on the y-axis. So that would be negative 2 is the lowest y value. And 4 is the highest y value. So we're going to call that negative 2 to 4 with brackets to show that it actually does touch those y values. Another review item. There's a thing called a vertical line test. Hopefully you remember that. A vertical line test is basically a way to visually tell if a graph is a function or not. And it's as simple as this. You have a function in this black curve. You take a vertical line, which is this blue line here, and you see how many times it crosses your function. In this case, it only crosses one time. So this is a function. On this second example, you take a vertical line, you draw it through your function, and it crosses twice. And if you have a vertical line test where the line crosses twice, that means that that is not a function. Basically, the reasoning is each input can only have one output in a function, and the vertical line crossing twice displays that there is more than one output at that particular point. Just a reminder, functions can be represented in 4 different ways. We're used to seeing a visual representation, which is a graph, or maybe a numerical in a table of data, or even an algebraic function, which is an equation. But you can also represent functions verbally with words. Here's an example of that. When you turn on a hot water faucet, the temperature T of the water depends on how long the water has been running. Draw an extremely rough graph of T as a function of the time that has elapsed since the faucet was turned on. So you will be doing this for homework, is actually drawing, sketching graphs to represent things. So this is T, which represents time. And then we're going to have capital T for temperature over here. So what happens to the temperature of the water? When you turn on a hot water faucet, is it always hot at the beginning? No, it's not. It's kind of cold, right? So it's cold and it slowly warms up, right? Gets to a certain temperature and then it stays at that temperature. Now, the water will stay at that temperature until a certain point in time, and then it'll slowly start to decrease in temperature because it's been on for a while, right? Running out of hot water. So your graph's going to look something like that with a plateau at the top. See what I mean by extremely rough graph? It's not real pretty, but you get the point. Okay, so the next thing we're going to review is domain restrictions. So basically there are times and different functions that don't allow for certain values because they don't work that way. I'll give you an example. If you think of square roots. Square roots have restrictions because square roots can't be negative. So we would say that that has a domain restriction because plugging a negative in to a square root would break the rules of math, we say. So what types of things have domain restrictions? You can look here. Square roots have domain restrictions because the inside must be a positive number. Rational functions, like 1 over x, has restrictions because the denominator can't be 0. And logarithms have restrictions because logarithms, the inside number has to be larger than 0. Just a reminder, log is a logarithm, but so is log. Okay? They're both logarithms. So find the domain of each function. So domain is easy to do when you have a graph. Here you have an equation and you're not using a graphing device to find these domains. You're going to do it algebraically. So what you're going to do is you're going to think about those restrictions. So you're going to say, okay, look, I got a square root. Do square roots have restrictions? Yes, they do. So because they have restrictions, we're going to start with what is restricted or what is not. So I'm going to say square roots have to be positive numbers. So I'm going to take the inside of the square root and write an inequality to show that this inside part must be greater than or equal to 0. Okay? And then I'm going to find out what x would need to be. And I'm worried about x because x is what determines domain. So I'm going to solve for x. And I get x must be greater than or equal to -2. So that's going to give me my restricted domain. But I would like you to take it a step further and to write it in interval notation, which it would be anything greater than or equal to -2. That would mean start at -2 and go up to infinity. That would be your domain. All right, for the second example, you do have domain restrictions again because you have a fraction and the denominator, x squared minus x, can't equal 0, because if it did, then that would be breaking the laws of math. So you're going to set an equation up and say that this thing at the bottom cannot be 0. So let's figure out what x would have to be, or what x can't be in this case. To solve this, I'm going to have to factor out an x. And then I'm going to have to set each one of these things up into their own little equation. And solve. So this first one's already solved, saying x can't be 0. And then over here I would add 1 and say that x cannot be 1 either. So those two values would create a 0 in the denominator, which would make that incomputable. If you wanted to write it in interval notation, it would be a little messy because you've got two restrictions here and here. But here's how it would go. You would basically say negative infinity to 0, 0 to 1, 1 to infinity. But you're using parentheses to say, basically don't include those numbers 0 and 1, skip over them. All right, last one here. So we have ln, which is natural log. That's a logarithm, which means this inside piece cannot be negative, and it can't be 0 either. So we would say it has to be anything above 0. So we're going to then write an inequality, add 5, and that means we can have anything greater than 5. In inequality notation, it would be 5 to infinity. Okay, the next thing up is a piecewise function. So this is, I write it, or I describe it as an easy concept that has ruined the day of many a calculus student. For some reason, people get really freaked out by piecewise functions. Really, they're not all bad. I am going to review with you how to graph one, and then we'll go back and evaluate the points. So just a reminder that this is just a function with a domain restriction, and then another function with a different domain restriction, and they're just all graphed on one graph. So if I wanted to graph this thing, I would start by graphing 1 minus x. That's a straight line that has a y-intercept of 1 and goes down 1 over 1. So I would graph it kind of like this. And then, let me get my line drawn. And then I'm going to apply the domain restriction. So that says that the graph only exists when x is less than or equal to 1. So anything past 1 needs to be erased. Only keep the part that is less than or equal to the x value of 1, so the left side of 1. So I can draw an arrow over here to show that it can go in that direction, but not the other side. Okay, second part, I have x squared, which is a parabola. And I'm not going to draw, well, I guess I can. Just trying to avoid overlap, but that's okay. So it would be a parabola like a U shape, right? But I would only want to keep the part that is greater than 1. Okay, I want to keep the part that's greater than 1. So let me see if I can undo without erasing and messing up my other line. There we go. Normally parabolas start at 0, 0, and then 1, 1, and then 2, 4. But mine's going to start at 1, 1, and then 2, 4, and so on, like this. I put an open circle at 1 because it says greater than, not greater than or equal to, right? So that's an open circle. Okay, let's go back and figure out what these evaluate things mean. So f of 0 is asking for the y value when x is 0, which you could use your graph to find. It looks like it's 1. Or you can use the equations. So the equation you would use is the top one, because x values that are less than or equal to 1 apply to that first function. So you could plug in the x value to that function. I'll show you on this next example what I mean. So f of 1, I would use the top equation to find that value because it includes 1 in its domain restriction. And I'm just going to take the function itself and plug in the x value that I've got, and then just do the math. So I get 0 for that. And you can double check on your graph and you can see that 0 is the right answer. Last one, what is f of 2? So 2 falls into the second category. X is greater than 1, well 2 would fit into that group. So I would use x squared to evaluate. So I'm going to do 2 squared, which is 4. So f of 2 is equal to 4, and I do have that point listed on my graph.